Thank you, Brian. Hi, my name is Pranay, and we are presenting a ACTIVecharge today. It's a wind energy innovation company. We are developing our technology at the University of Maryland system, and it primarily how to take the next big step towards blade monitoring. Next slide, please, Ben. Yes. So what is so important about our technology? And what is so important about monitoring the blades? The wind turbines are getting bigger and bigger, and the blades are getting bigger and bigger as well, and they're always moving. And it's very difficult to an idea. Many of all these days, the blades could be 100 meters or more. And how do we monitor them? Because if there is a lightning strike, the blade gets damaged. If there is unusual vibration, the blade gets damaged. Or if there is any other problem with the blade, and if we don't monitor it, it becomes a problem if we don't monitor it regularly. So how do we do that today? We either send people up the climb, which is very costly. It takes time. We have to stop the turbine, and it's dangerous. Or we could use batteries, but these batteries will run out every 6 months. And if you have several different sensors in the blade, I mean, you will keep on changing the batteries in the blade, and it becomes a big problem. Wires, I mean, instead of using batteries, one could use wires in the blade, but of course, that provides a path for the lightning to come down and increases the lightning risk. And as the length of the blades is increasing, this situation is getting worse because we need to monitor more, not less. And here we don't have a good solution. Next slide, Ben. So our solution is self-powered. It sends the data wirelessly and collects all the data to provide actionable analytics so that we can dramatically increase the efficiency of wind turbines, of any wind turbine which is 1 megawatt or more, and it does not require a battery replacement. It has very dependable, frequent data that comes down wirelessly. And of course, it can provide predictive operation and maintenance insights, which is currently not available. Next one, please. And we believe that one of the major things is we are not increasing the O&M cost, which is currently the cost to monitor the blades. We're not increasing that at all. However, we are reducing the manual monitoring portion by 75%. We don't need to send people up. We don't need to change the batteries. We don't need to stop the turbines. And that reduces the current cost by 75%. We don't need to stop the turbines, reduces or increases the downtime by 2 or 3 days a year, which is big. And of course, because we have so much data, the probability of catastrophic failures is reduced 10 times. And all in all, we believe that it is 4 times the value than the existed blade operation and maintenance. That's what is being done today. Next, please. And we are happy to say that the wind turbine industry is increasing. The whole market is exploding, not only globally, but in our neighborhood, in Maryland, in New Jersey, in Massachusetts, wherever we see, both offshore and onshore, the wind turbines are increasing. And we see rapid growth during the ACTIVecharge scaling years, meaning that years when we are trying to scale our work, the number of wind turbines, the number of the market available to us is very, very substantial and growing. Next, please. And of course, not only the new wind turbines, but the existing turbines that are going to be refurbished. They are going to be retrofitted, for example, in Europe, which is slightly ahead of us. But even in the US, we can retrofit those turbines as well with our devices. And that presents another huge market for us. Next, please. And if we see the wind turbine industry, everybody is looking at every penny if they can save it. And if our device, our solution can help them reduce their own. I think there is a very receptive market, and we believe that with our 4 times the value than cost, we believe that we have a very good market, which we believe is about $1.5 billion per year blade monitoring market by 2024, when we believe we will be reaching up to some scale. Next, please. And we believe this not only a market, but we also believe that the competition is still catching up. There are interesting concepts in the market, but compared to what is available today, for example, the sensors are not self-powered, they can't monitor everything, and of course, they can't communicate very well wirelessly with a central receiver. Competition, all of them are making good progress in their own ways, but we believe that we offer the most comprehensive, forward-looking, innovative solution as compared to the rest of the competitors. And also, we may say that we are patenting this technology, this solution, so nobody can copy us as we go. Next slide, please, Ben. And we started the company about 2 years back, and since then, we have been in touch with the market as much as possible, and because that provides us the market insight so that we can develop the product in consultation with the market, not in a vacuum. And I'm pleased to say that we are in touch with one of our big wind turbine manufacturers, Siemens Gamesa. We are in touch with GE Renewable Energy. US Wind, that has the license to build Maryland's first offshore project. They're based in Baltimore. We have a strategic partnership with them. And we just received a strategic sponsorship from Exelon Corporation. And I think that collaboration, that sponsorship is taking us far quickly towards the market. I was able to speak to several of the independent service providers in Germany this March, Deutsche Windtechnik, UV, and our Alpha Energy, which is based in work with industry, so that we get the right feedback into our product development, but also quickly move on to the commercial stage when we are ready. Next, please. And we not only the product, but we are also presenting, and in that process, we will be able to provide not only the product, but also run it for the wind turbine owners, and also provide all the analytics so that the whole process can be integrated. And on the other hand, we are with the wind turbine maker throughout the life cycle of the wind turbine, which is about 20 years, instead of just selling them a product. And towards that end, we have tried very hard to make our design very low cost, very robust, which is very easy to install, and we provide the whole service end to end, making it a very attractive proposition. Next, please. Our team is our biggest asset, and it's myself and Dr. Subham Lee, who actually started the company. He is associate professor of mechanical engineering, great resource for us. Dr. Ahmed Abdulaziz, our technology VP, and of course, Eric Desrosiers, who has been working with us on the financial side to come up with a nice model for the finance. And as you can see, we have quite a bit of breadth and depth into the skills and resources that we need. And we believe that as a start, we are a very good team that's working together. And of course, we look forward to expanding our team. Next, please. So from our perspective, we believe that we can make this company profitable within 4 or 5 years. And let's start from today, or rather from last year. So the first award that we got was from TEDCO. And we now have 2 investment rounds from TEDCO, MEIA investments. And they have been a great help in helping us connecting with lots of people within this region. in addition to the financial input. And last year, we also got in touch with US Wind. We have a strategic partnership with them, as well as this year, we are fortunate to be part of MEIA first cohort. We have greatly benefited from that. And as part of that, we were able to get Exelon sponsorship as well, strategic sponsorship. And now we are in the process of field testing our solution, first on a smaller scale, then of course on a bigger wind turbine. And lots of companies are helping us with an aim to have a commercial launch in 2022 and reaching profitability by 2025. Next, please. So to realize our vision and milestones, we at this time believe a $500,000 investment can help us realize our plans in the next year and a half. And we believe that we can use that $500,000 investment, 75% of that in further developing our product so that it's ready, fully ready for the market. I think at this stage, I would like to thank the judges and the audience, and I'm ready for
Great, thank you, Pranay.
questions. Thank you.
So we've had a little bit of technical challenges, Pranay, so we'll do our best with the Q&A, and we'll start with Curtis, and we'll go in a round robin fashion from Curtis to Claire to Michael. So Curtis, please go ahead.
Thank you, Pranay. Really enjoyed your presentation. I guess my first question is, how and where do you install these sensors, and what types of data are you collecting from each asset?
So if I understood the question, because it was a little bit break up, how do you install it or where do you install it?
And what types of data are you collecting from each asset?
No, I still couldn't understand the question. If you can write it as. Okay. So typically we would go 9 to 12 sensors for a 1 megawatt to 2 megawatt wind turbine. That's how many sensors in each blade. And the data could be vibration data, it could be ice accumulation data, it could be temperature, any kind of sensor that you need in any part of the blade, which is very difficult to reach, our device will reach there and provide data, live data from there for the life of the turbine.
Claire, you want to go ahead?
Sure, and I just texted the question to Pranay as well. Nice to see you, Pranay, good job. Can you share more information about your business development plan? You say you've been in conversations with Siemens and GE. What does that mean? Are they buying your product? Are you in some sort of partnership? It'd be great to get a little more information.
So with GE, the discussions are just initiated, but for example, with Exelon or even our business model is they will buy, I mean, they already have the sensors in many situations, and we will be selling them just the product and integrate it with their existing sensors. So the installation cost is very minimal, or the one-time cost is very minimal.
Michael, do you want to go ahead?
Yeah, so here I just put this question in the chat as well, but Could insights gleaned from these sensors feed back into next generation turbine design and enable things like reductions in the amount of steel? Or in other words, is there a virtuous cycle to take advantage of?
Yes, and a big part of our solution is how much more data that we can get from the blade turbines. I mean, blades of the turbines, because that's what is missing right now. We don't even have the blade data, and with our solution, when the data is available, dependable, frequent data available, we can do so many things. We can make the wind turbines more efficient. We can make them, we can help them design them better so that we use less material. We can do efficiency at the percentage rate, which is a big thing, because now we know if we run these turbines a little bit faster or a little bit slower, the wind turbine may actually be much more efficient. So yes, data analytics is the most critical output, the most important output of our solution. Yes.
Well, back to Curtis if you have a follow-up.
I do, and I just sent it again. So my question is, what is the communication protocol that is used by the sensors, and how are the end users, whether it's the OEMs themselves or a customer like Exelon, using this data?
Yes. So the communication protocol that we are using is Zigbee. And we have also looked into a couple of other protocols as well. And that is actually part of our field testing right now. As we speak, we are preparing our tests and doing that. And also, it is independent of the data transmission that they are using, because we are giving them analyzed data, which will be, on the internet backbone that actually is there right now in the wind turbine. So we can integrate with their solutions as needed.
Okay, Claire, you want to read your next question?
Sure. Can you discuss the unit economics a bit more? What are the costs to you, the sales price, the cost comparison with other technologies?
So Claire just wrote a question regarding the unit economics. So we expect the cost of the product, as we have done until now, in the range of $300 to $500 each. But please consider that this is a test product, and when we start making this in bigger numbers, the cost is going to go down. Okay, and we model with the people or the companies that actually install this, and we will be providing them a service. The cost of this product has been kept very low, as well as we have taken great care to be able to attach this to existing wind turbines. So all of that is going right now, and we believe that we'll be profitable by 2025 and break even in a couple of years after that.
Okay, Michael, would you have a follow-up?
Yeah, I put it in the chat as well. What specific sensing or analytics milestones have been demonstrated to date, and at what scale have those been achieved?
Okay, so we have been working on this in the lab for about 1.5 years, and we have a real vibration sensor. Vibration is one of the major in the lab, and now we are working on a field test, and of course we'll be testing for 3 different sensors before we actually, as part of the next several months, lightning, vibration, and ice. These are the 3 sensors we're going to start with, but of course we can integrate with all kinds of sensors.